Welcome to The Explainer. Today, we're diving into a pretty radical theory that asks a really mind-bending question. What if the universe isn't made of things at all, but is made entirely out of motion?
Okay, let's just jump right in. The quantum world is famously, well, weird. You've got particles in two places at once, and the simple act of looking at something changes what it is. But what if all that strangeness isn't a fundamental feature of reality? What if it's actually a sign that we're looking at the universe through the wrong lens, using the wrong tools to understand it?
To really get why anyone would even bother coming up with a new theory, we first have to understand the major roadblocks facing physics today. For decades now, a lot of physicists have had this growing feeling that they've kind of hit a wall. Yeah, this quote really gets to the heart of it. A lot of physicists describe trying to fix our current theories as a game of whack-a-mole. You solve one problem, and another one just pops right up. They even compare some of the really complex ideas like extra dimensions to the old epicycles from ancient astronomy, where they kept adding more and more complicated circles to a broken model of the solar system just to make the math work, instead of asking if the model itself was wrong. And the problems are deep. I mean, really deep. You've got the measurement problem. Why does just looking at a particle force it to snap into a definite state? It's bizarre. Then you have the huge unification crisis. Our best theory for big stuff, general relativity, and our best theory for small stuff, quantum mechanics, they don't talk to each other. They're written in different languages. And all this has led to a kind of stagnation, where we have tons of beautiful mathematical ideas that we have no way of actually testing in the real world. So this whole crisis really created an opening for someone to come along with a completely different idea. Instead of just patching up the old system, an independent researcher named Dewey B. Larson decided to start over, to build a whole new system from the ground up. And Larson's idea was a huge shift in thinking. See, pretty much all of mainstream physics is vector-based. It describes objects that have a specific speed and direction moving through these containers we call space and time. Larson's idea was that the universe is made of motion itself. That's it. In his view, space and time aren't containers at all. They're just two reciprocal aspects of motion, kind of like two sides of the same coin. This is a scalar-based system, which only cares about magnitude, about rates, not direction. Okay, so Larson created this foundational framework. But what's really interesting is how another researcher, Douglas Bundy, then picked up this framework and used it to build a specific theory aimed right at the problems in quantum mechanics.
So this is a really crucial point to understand. Think of Larson as the architect. He designed a whole new set of blueprints, a new language for doing physics. Then Bundy is the builder. He took those exact blueprints and used them to construct a very specific building, a new theory designed to explain the quantum world. So the final result isn't Larson's theory, it's Bundy's theory, but it's built on Larson's framework.
And the name itself actually explains this relationship perfectly. B is for Bundy, the builder. RS stands for reciprocal system, but here's the key. It's used like an adjective describing the kind of theory it is. And that little lowercase t at the end, that's actually a huge detail. It's there to show that this theory was developed under Larson's new system, not the conventional Newtonian system that's the foundation for almost all of modern physics.
So how does this whole thing work in practice? Well, by using Larson's system, Bundy's theory ends up challenging three core, almost sacred ideas in physics. I mean, these are so fundamental, they're basically heresy.
Heresy number 1, space and time. We're all used to thinking of them as the stage, the big empty box where the play of the universe happens. This theory says there is no box, there are no containers. Space and time are simply the two faces of motion. They only exist because of motion. Heresy number 2 is all about space-time. In conventional physics, you always hear about the fabric of space-time being bent and warped by gravity. Well, in this new theory, space-time isn't a substance. It's not a fabric. It's just the bookkeeping. It's the measured relationship between different bits of motion. It's the spreadsheet, not the actual stuff in the spreadsheet. And the third heresy might be the most mind-bending of all. It redefines what a point even is. We think of a point as a location, right? A dot on a map. This theory says a point isn't a location at all. It's a resonance, a specific, stable harmony created by different quanta of motion. It's way less like a dot on a graph and a lot more like a specific note in a musical chord, defined by its frequency. And what's so cool about this is that this whole new way of thinking,
seems to connect to a really mysterious number that's been popping up in physics, kind of haunting it, from the very beginning.
And that number is 4.
Seriously, for over 100 years, the number 4 has been this unnoticed elephant in the room of physics. It showed up in one of the very first quantum formulas, way back in 1885. It's at the heart of quaternions, a 4-dimensional number system. We have 4 fundamental forces, and even today, we use exactly 4 quantum numbers to describe what an electron is doing. This new theory suggests this isn't some weird coincidence. It's a deep signature of the underlying structure of reality, and it just falls out naturally from the theory's basic principles.
So, what's the takeaway here? If a theory like this holds up, what does it mean for the future of physics? Well, the implications are absolutely staggering.
To put it bluntly, it's an iconoclasm, a shattering of idols. When you shift your whole perspective from a vector-based view of objects moving through space to a scalar-based view where reality is literally built from ratios of motion, you're not just challenging a few equations. You're challenging the very foundation of how we've been reading the language of the universe for centuries.
And that leaves us with one last really provocative thought. For hundreds of years, our starting assumption has been that the universe is made of stuff, matter, and energy. But maybe, just maybe, we've been asking the wrong question the whole time. Perhaps the most fundamental ingredient of reality isn't a thing at all. Perhaps it's an action. Perhaps the universe isn't made of matter, but is, in its entirety, made of motion.